All right, awesome. Okay, well, thanks everyone for showing up. We'll be respectful of everyone's time here. Hi, I'm Ryan from Elastic, based out of New York here. A lot of you probably saw a bunch of emails from Peter Kim. He helps run the Meetup group. He's also based here in New York, but unfortunately could not join us today due to obligation in DC area. So thank you all for coming again. Help yourself to everything. If you didn't see it, restrooms are outside there and to the right. So today we have, we first want to thank Yodel for hosting this location and everything. We really appreciate it. They've done it in the past and are very good that way. So Mark Drago here from Yodel is going to give a short talk, probably around the 30 to 40 minute range, depending upon how many questions you guys got. And then afterwards, we'll have Q&A with him, and then also myself and many other Elastic employees happen to be in town this week. We have everyone from myself on the education and engineering side to some pre-sales people to some sales folks in the room. So anybody you'd like to speak to, we got pretty much all disciplines covered. So we'll do Q&A on that, anything coming up. And then there's stickers up front too as well, and sort of run it that way. So without further ado, turn it over to Mark.
Great, thank you. Yeah. So my name is Mark. I've been here at Yodel for 6 years. I work in an engineering department with a bunch of great folks who are here. We work in this division called YBN, Yodel for Brands Networks, and we help franchises, and I'll get into that. But so this talk is, it's really a story about how we transitioned a product from Hadoop to Elasticsearch, and kind of why we started with Hadoop, how that went, when we learned that it wasn't going to be great, and how we switched. Right, so it's a story about how we got from there to where we are today, to here. So real quick, in order to understand this talk, you're going to have to get a little bit of context about what Yodel does. So Yodel, we're all about helping small businesses be successful online, in particular with online marketing, but we get ourselves into more and more every day. We also have a product called Lighthouse, which helps dentists, get people in the door every day by automating communications to their patients, and we're expanding that into other segments outside of dentistry as well. We have a product called Centermark, which is what this talk is basically all about, which is focused on franchises. So we're helping a franchise with all their local marketing challenges, visibility into what's happening in their franchise network, and helping them take actions at scale. And then Yodel was acquired by Web.com back in March, and our missions kind of overlap very heavily, so we're really excited to kind of join forces and help even more small businesses. So that's kind of Yodel in 60 seconds. What do we use Elastic for here? So we have a few different things we do that leverage Elastic. One is kind of more traditional stuff that kind of looks like document search, where we have a bunch of documents and we need to find the ones we want. So we have a CRM system that we provide, so I want to find a bunch of people with this name or that have bought this product in a given month or whatever. And we use that to power our email marketing lists product, where I can make a list and say I want to email people that over or underpaid for whatever it is. You kind of make this list and we can send them emails. We also have an elk stack in-house, so we are consolidating logs. We are pretty big into the microservices architecture. We could talk about that for an hour, but we got plenty of those, all funneling logs together, making it easy for developers to see what's going on, not to mention a bunch of systems that are not really microservices, but a ton of stuff flows in. And then we have this business intelligence product, which is gathering marketing data for our customers, kind of bringing it all together and providing them with charts and reports that help them understand what's going on in their network and what they could be doing better, or whatever they need to be doing. They get visibility through this tool. So that BI product is called Centermark, and that is what this whole talk is about. So that's a bunch of context on Yodel. The next bit of context you're going to need is to understand franchising, and I'm going to do this in about 60 seconds. So, you know, when I imagined a franchise before I got this involved with them, I pictured, you know, like McDonald's or Subway, like these gigantic companies with, you know, 30,000 locations in the U.S. or something. Our customers tend to be a little bit smaller than that. One, we don't really work with restaurants. Two, they tend to have, you know, a few dozen, a few hundred, and up to a few thousand locations across the country. So a little bit of a different scale. But they still have this problem of, you know, they have a ton of locations, and they're trying to help them distributed across the country. So so they kind of bring a bunch of people together. These like people who are going to be great at marketing, at selling franchise locations, and they consolidate all that into what we call a corporate entity, which is like this, almost like this doom and gloom term. But I always pictured it as these giant companies, like, oh, the corporate center of a franchise. That must be, you know, in the really big buildings with hundreds of people there, all working on this problem, just endless resources. But it's really not that way. Our customers tend to be, you know, a more modest scale, right? There's a business there, and it's sizable, but they don't have endless resources. In practice, in the marketing department of our customers, there's like one person or two people that's running marketing for a nationwide franchise. So, you know, they end up with this problem where they have hundreds of locations and there's only a few of them. So, you know, my wife and I, we have 3 daughters under the age of 6. And if they become like geographically distributed, that's a real problem because we're like on the wrong side of the ratio, right? It's like 3 to 2. But these people, they're dealing with a 3, 4, 500 to 1 ratio of these geographically distributed franchises that are all running off in their own directions. So, you know, very quickly this problem kind of adds up and they struggle. So they spend most of their time kind of like this guy where they're, you know, okay, what's going on with this location? Let me kind of help them out. Okay, what's going on with this location? Let me help them out, right? So Centermark is designed to give these guys the data they need to make the best decisions for their network and the ability to take actions at scale and make things better. So we've been working on this problem for a little while. So I'm going to run you through like quickly the progressions of this product. So back in 2010, 2011, we realized, okay, like our customers kind of need all this data in one place. They need to see what's going on across the network. So we just jammed a bunch of numbers on one screen in one like gigantic SQL query that we ran. This, you know, worked at some scale and at some point, but what we found is I got some numbers here, for 15 locations, this would take, this page took, oh sorry, for 25 locations, it took 16 seconds to load, which is not great, but like, okay, I can wait 16 seconds to get a month's worth of data. If you had 500 locations, this took 4 minutes to load, which is not really workable, right? Like that is, like you've given up minutes for a page to load. So we became laser focused on improving the speed of this product. We said, okay, 4 minutes, that is not acceptable. Our clients are telling us it's not acceptable. So we are going to fix this speed problem once and for all. So we built another version that was a little bit better than slapping a bunch of numbers on a screen. And we were so focused on speed, we lost sight of a few other things that were important, and that's kind of later in the talk. What was great about this, though, is that we definitely nailed the speed. So we were loading data here in 200 milliseconds, and that's from when you want the data to when you get it, and I'll explain how we did that, but it's not a great story. So The speed was good. Everything else was kind of, well, whatever. So we said, okay, we need to focus on more things. We can't just be focused on speed. We've got to get everything right. We still need it to be fast, but we need to hit all these other requirements that our customers had. And eventually we built a product which is like the kind of the good end of the story. And we're going to go into a bunch of details, but this is what the newer product looks like. So I'm going to heed the wise words of Kevin Hart and kind of look back at what we did in the previous version, just so we can kind of compare what we have today. Compare that to what we have today. So this is the architecture of a system we built in the fall of 2013, which 2013 sounds like a long time ago, but it's just like 2.5 years, so it's still pretty close. But so I'm going to walk you through this a bit. So we have this Postgres database, which is the thing we were abusing with that giant query earlier. It holds a ton of data, all like the real, what actually happened. It's the source of truth here. And we said, all right, we got to get it out of there and into something else. So we had these uploaders that were taking data out of Postgres every hour or every day in some cases. And they would just say, okay, what's the latest data? What has changed in the last day? And it gets uploaded into S3 in the Amazon S3 system. And then we used EMR, the Elastic MapReduce offering from Amazon, to run Hadoop jobs on that data, which we wrote in scalding, and I've got a little bit on scalding in a second. So that would crunch all this data. It stores the results back in S3, which is nice, but we can't, we need to get them a little closer to home. So we have these downloaders that would go out to the S3 buckets, get the set of results, load them into hbase, which we were moving towards at the time and we're moving away from now. And then we would query hbase for these pre-aggregated results, right? So this is how we got that 200 millisecond load time. Is at load time we were doing almost no work. It was, okay, which numbers do you need? I got them right here. Show them on the screen. It was no math at that point. So that's kind of the quick overview of where we were. So quick aside about Hadoop. Is everybody familiar with Hadoop? Like everybody use Hadoop? Okay, good. So the way I see Hadoop is at some point, we discovered we can make the word count problem really fast by distributing that word count problem really widely. And then we realized, we can make basically every problem look kind of like a word count problem. Hadoop was born, I guess. So Hadoop lets you write these, mapping steps and reducing steps and kind of combine them in interesting ways to get the data you want. When we were looking into producing the system, we looked at writing straight Hadoop jobs and we said, you know what, that's lower level than we really want to be operating at. So there's this library called cascading, and cascading is a Java library. Kind of you write Java at a higher level where you're using abstractions and it produces the MapReduce steps for you. So you're not piecing together these small pieces, you are working in higher level abstractions, which is nice. We chose to use scalding, which is a wrapper around cascading. And what scalding does is it makes all these operations look like Scala collection operations. So at the time we were embracing Scala pretty heavily and liked the collections library, so we said, great, we can just write what looks kind of like Scala and end up with stuff that we can run on 20 nodes at a clip. So quick kind of run through of scalding, and this is the reason I'm showing this is to show how engineers were working back when we first built the system. So if you look up here, what this is saying is this is talking about sessions. A session for us is a web visit. Somebody went to a website, clicked around a little bit, and they left. There's this session that they left behind. So this is a filter step, so we have more sessions than we want. We want to get rid of some of them. And what we're saying here is we're going to call the filter sessions method, And if that returns true, we're going to keep that session. If it returns false, we're going to let it go. And we're going to operate on these three fields: the referrer, this ignore boolean that is set magically. I actually don't remember how it's set, and the IP address of the visitor. And this is just saying, check is the URL, the referring URL a bot? Is it set to ignore? All this stuff, and it says, keep it or don't. So this is like how a filter operation would be done in scalding. This next bit is where it gets a little bit more interesting and you kind of get to see the power of scalding. So what we're doing here is we're joining two different data sets. So we have these filtered sessions that we filtered, and we're combining these sessions with this FMA client thing. An FMA for us is a franchise master account. Really, it just means like the franchise. So we're trying to group all these sessions into, okay, these are the sessions for this one franchise, these are the sessions for another one. So we're able to join them that way. And it's very high level. Like it really was kind of a pleasure to write. It felt like really powerful to write just a few lines and know that it was going to execute on 20 or 30 nodes in Amazon and have billions of things run through it, and I don't know, it was kind of cool. And this is a mapping step where we're doing some math. So we have the begin time of the session and the end time of the session. So when you first visited the page and the last page you visited, and we want to get the duration, and we're doing basically subtraction in this method. So it's just a simple kind of mapping operation. Then this is kind of more interesting still. So what's going on here is we've done a bunch of work. So we filtered sessions, we've kind of enriched the data a bunch by doing this duration calculation, a bunch of other stuff, and we're getting close to saying these are the final numbers we want to put in front of a franchise customer. So this group by is saying group everything by the franchise they're in, so we get separate numbers for different customers. That sounds good. And group them by month, and that month is a month and a year. So it's saying, what happened for this customer in May? What happened for them in June? Right? So it's separating these things out, and then it's running a bunch of sums and adding up all the sessions, all the page views, all of the whatever it is, right? There's a few problems that really, like, problems in that entire system I showed you earlier are in this, they come out in this one line. So first is right here. So we're saying group by month, which is helpful because you kind of want to see stuff over time, but month is really not very granular enough. Like, you can't make decisions only seeing numbers at the month level. Like, you're operating, you're making changes day to day, you're running a campaign for a few days, you want to see what happened, and we're saying no, like, the only visibility you can get is at the month level, which isn't great. And the other problem is here at where we're grouping it with the franchise. So it sounds great to say, all of this franchise's data is together, but really that franchise wants to be able to look deeper and say, well, what's happening in the state of Florida? I have 20 locations in the state of Florida, and I want to know how they're operating, what's going on there, separate from some other state or whatever. And we were saying, no, you can only see it kind of aggregated all the way up at your whole network. Those were two problems we had. A few other challenges we had to overcome. So this is one of those problems that I think comes up in a lot of these data moving systems, and we definitely encountered it as well, which is historical data for us can change in a few different ways. So one way is somebody gets a phone call. We track those. We know how many phone calls these businesses are getting, and we let them rate the call. So they can say things like, this was a telemarketer, or this was a wrong number, and we'll remove that from the data because we want to give them just information about, if a telemarketer called you, you can just pretend that didn't happen. We want to take it out. Other ways historical data can change for us is, we were filtering bots in that code I showed earlier. Maybe we identify some new bots that we want to filter out, and we have to kind of go through historical data and do more aggressive filtering. So there's a problem with history changing. And then dealing with that history changing problem. So I'm going to show where these differences are because I found that if I don't, basically nobody pays attention to what I'm saying, and they just try and play the game. So there you go. Sorry to ruin your fun. But when you're comparing, we ran an aggregation yesterday. We have all the results, and then we have new data arriving today. Some of that data is fresh. It's stuff that just happened, but some of it is changes to historical data, and we need to make a decision. Like, how are we going to identify the changes? How are we going to take the right action, right? Because if data is fresh, we just want to add it to the system. But if it's representing a change, we may need to subtract and add. And that is figuring out which you should do is really important and not very easy. This is all identifying the differences is not that easy. So what we said was, okay, can we make the whole system idempotent, right? So idempotency is a feature of a system where it will give you the same result even if it has received messages more than once. So can we make any one message here, like if we hear it a few times or we get updates, can we build the whole system in a way that it just deals with that and gives you the right answer, exactly what you'd expect? So we figured, okay, let's try to get as close to that as we can. So we decided to we looked at the whole problem, and we said, well, we need to be able to aggregate all of our data sometimes. So sometimes, we added a new bot to the filtered list, we have to look at every session again. Or if there's a bug in something, and we say, okay, well, to fix that bug, we need to look at every piece of data again and re-aggregate. We also need to deal with fresh data that's arriving and this changing data. So we said, all right, let's just re-aggregate everything every single night, right? How bad is that going to be? And we did the math. So I figured, how long would it take a team to build a system that can identify differences and all that? How risky is it? What are the chances that we get it right? How expensive is it to build relative to the cost of running some Hadoop jobs that maybe we didn't have to run? And we decided to just run it again. So that was something we did. We just re-aggregated basically every piece of data that we had every night. And we did that for a few years. It worked out fairly well. So that kind of that's where we left off in 2013 with that Hadoop system. And then a bunch of time passed. And we started hearing from our customers, and they were saying, hey, you're showing me data, but the resolution on that data is really bad, right? I can't use what you're showing me to make decisions about my business, which is, the whole point of this product. So I said, okay, we need to deliver on the flexibility here. We need to let them get reports, look at charts for arbitrary, I'm ruining my jokes, for arbitrary date ranges. So, what happened on these 3 days, what happened in this 45-day period, whatever it is, we need to give you that visibility. We need you to be able to slice up your network and say, just show me Florida, just show me this region, just show me people that are whatever in this budget range or whatever it is. And we still need it to be fast, right? We can't say, oh, well, it's going to take 4 minutes. So we looked at the system we had. We looked at what we were doing with scalding, Hadoop, this hbase thing, and we said we can't make what we need with what we have. We just can't get there. So in order to, the way I see it, in order to deliver on the flexibility of date ranges and all this stuff, we need a powerful page load time query engine. There's no way around it. We simply cannot pre-aggregate everything that the customer is going to want to look at. So, all right, well, there's a lot of tools out there, right? How many could there be? We'll just look around at what's going on in the, this data space. Sure, there'll be a few that stand out, and there's a million different options. So, all right, well, what are we going to do? What are we going to do? So this coincided pretty to our benefit with a hackathon. So we run internal hackathons here every few months where teams form, they pick any project they want to do together, they spend a day or two kind of working on demo it in front of the company. So it's time for the engineers to experiment, play with new technology, some new part of the business, whatever it is they want to be doing for a few days and then talk about it. And one of the groups said, hey, we're going to experiment with Elasticsearch and see if we can use it to solve our Centermark problem. And they did. I mean, it was really rather impressive. They took data from our largest customer, and they were getting great charts and reports out of it in just a few days. And I said, well, so when it really came time to invest in the project, get many people involved, so all right, well, we've got to do some more research here because this is a big decision. Like, we're going to be betting like this product on this decision, so we've got to scale up the test. So they had only used a subset of our data, and I was like, well, we got to try it with everything. So we had all this data in S3 that we were running through these Hadoop jobs. So we cooked up like a 100-line Python program that would read all these files out of S3, parse them, convert them to JSON, and load them into Elasticsearch using the bulk insert API. We were running Elastic in EC2. So what was great about this is we didn't have to download all this data again or load it locally. We just ran it all on Amazon's end, all the free bandwidth we want. And it would take 12 hours, 18 hours to load all the data in. And we started running queries against it, started saying, well, what if we query like this, and what if we slice it like that? What if I only want these locations? What if I need 5,000 locations, whatever it is, or I extend the time range really far? And I was kind of blown away. It was really fast, and it was almost like so fast that I was skeptical of it. Like, I don't believe that you gave me that data that quick. So it was a good surprise, but still. But again, I said, this is a big decision. Like, if I was buying a car, I'd test drive a few before and that's just this is probably a bigger decision than whatever car I'm driving. So we experimented a bit more. So we had all this data in S3. Redshift had been announced recently, so we said, all right, let's load all this data into Redshift and see what Redshift can do. And truth be told, it held up as well. Like, we got pretty good performance out of Redshift. So we're looking at these two, and it's like, well, either one of these would probably work out. Like, maybe one road is easier than the other, but if we had to choose one of them, we could probably make it work with either one. But we looked at we already had Elastic experience in-house. We were pleased with what we were seeing there. We already had a support relationship with Elastic that we were happy with. Elastic for us had demonstrated like a consistent pace of innovation that we kind of wanted to hitch ourselves onto. It would also give us flexibility for where we wanted to run it. So if we use Redshift, we're tied to Amazon. Like, you're not getting out of there. We're running Elastic in EC2. We were then and we are now. But still, if we wanted to move it, we could, and that was a selling point for us. So, we chose Elastic. So that's great. We've chosen kind of the heart of the system where all the data is going to live, and we're pretty confident it's going to deliver for us. But obviously, there's more to build. So this was the first drawing we made of the Centermark 2, the new architecture. Don't worry about reading the details because I've got it drawn out a little nicer here. Again, we have this Postgres database that's kind of hosting, it's holding all this real, like the truth data, the source of truth. We have this new service called Data Pipeline Service that is running jobs, run them every 5 minutes. So we try to get data in very quickly, and it puts it into a Kafka topic. And this has been a great change. I kind of wish we had done this the first time, but making this data available in Kafka means if any other part of our system wants to just hook in and get session data or get lead data as it's happening, they don't need to worry about getting it and querying Postgres and trying to do all this. Like, we've handled that. Just listen to this topic and you'll get all the phone calls, all the web sessions, whatever it is. So I don't know if you guys saw the map we have in the lobby over here. I was talking to a few people about it. That is showing web visits, phone calls, and form submissions on websites by listening to these topics. So it's not, it's really kind of something to see, and it shows the impact we're having for small businesses. And that was built on these topics, actually as part of another hackathon. So things are kind of starting to stack up. So then we have a storm topology that listens in on these Kafka topics. And that topology, I mean, it's really its main job is to get stuff out of Kafka and to put it into Elastic, but we also do some transformation there. Some simple, I think we do the session duration calculation there, a few other things that kind of enrich the data on its way to Elastic. Elasticsearch is there. Don't need to go into too much detail. And then, I made these little blue boxes on it in advance. All right. So the data is in Elastic, and then we have this Elastic reporting service. An Elastic reporting service is the whole system is built by showing a bunch of charts, right? So our customers log in, they get a dashboard, and they can flip through a bunch of charts about all their data. Elastic reporting service is housing the Elastic queries that drive those reports, right? So it's like, oh, you want to see the report for your PPC spend? Well, I know which query to run. I know what index it hits. It comes back and gets loaded by the UI. So that's really, we call it ERF, is housing all of these queries. And then the data flows up through Analytics UI. We're using AngularJS and amcharts to kind of draw the charts for us. So what have we learned from this? So one is like the tools you choose is like a really important decision. Like it impacts you. I mean, it's not that surprising, but choosing tools that so what do you want to have close by when things start to get complicated? And I think the choices we've made in this system, we have a lot of options. So some new feature, something's compelling. We really should be building this. We really should be building that. It's like, well, we can put that back in kind of the pre-Kafka layer where we're querying for data. We can put that in Storm if we need to do some modifications there. We can do some interesting things with Elastic queries to get the right data. We've leveraged amcharts a lot. So I think by choosing the right tools, we've been able to progress pretty quickly. We're really happy with them. Another thing we learned, and this probably should have learned this in 2013 or so, is the development speed of these reports, these charts, really matters. So, we're not building like 2 of these reports. It's like these charts. We're building, dozens or 100. So, what is an engineer going to have to do to get fresh data into the system? What's an engineer going to have to do to create some new chart, some new report for our customers? Here, these are the 2 architectures, the one I showed earlier and the newer one. And you don't really worry about the details. We already did that. But let's say an engineer just wants to add a new chart on existing data we already have in the system, right? So we've loaded the data. It's like sessions. And we say, you know what, we want to see data this way. In the old system, you had to modify all of these pieces. So you had to go back to scalding, change that Scala code I showed earlier. That would get stored in this S3 bucket. You had to change the downloader because now you're like parsing the results a little differently. We had to find a spot for it in hbase. We had to add an endpoint, like a service endpoint to this reporting service, and then we had to find a spot to put it in the UI. So getting fresh data to our customers was a pretty expensive operation, which is really not where you want to be. In the new system, all we have to do is drop a new report in this Elastic reporting service. Right? Adding new data providing new data to our customers is write an Elasticsearch query, put it in the right spot in this service, and you're pretty much done. Like give it a title, whatever else. The UI is data-driven, so it responds. It knows what reports are available, shows them in the UI, and can render them without even being redeployed. This is a huge win for us. So we still had all these problems of changing data, but a lot of them become a lot easier. So instead of having to deal with like, okay, we'll just rerun this 8-hour Hadoop job every night, we just overwrite the data in Elastic, so using the ID field. So oh, there's a new version of this session, well, just overwrite the document and the next query that runs will show the latest data. So kind of became a non-problem. And that, again, is just about focusing on this item potency. Like this property ends up helping at many layers. If you can just keep that property alive, it makes a lot of weird things kind of go away. So, our customers had this blurry view of data. Well, it's not even really true, because what would happen is we would provide them this this data that wasn't at the resolution they wanted. So we had a team of people here that were producing custom reports for them. So they would still get the data they needed, but at increased cost to us. They couldn't do it themselves. But now they log into the product and their data is crystal clear, which is great. This isn't our UI or anything. It's just my Photoshop skills. So another great thing about this product is the whole business is really confident in it, which it's really been great to be a part of that. So here is we call the Centermark Insight Summit. We flew a bunch of our customers to a meeting, and we talked to them about their challenges and what we're doing. And this is kind of the room of people toasting the release of our new Centermark product, and they were all, really kind of blown away. So it was great to be able to show this the engineers and show people are really appreciating the work that they put in. So the champagne is great, but also engagement with the product is up. We're seeing the number of logins we get has doubled since we released this newer version. So we're really happy with that. Here's a ton of information just about our Elastic installation. So we run 5 nodes in EC2. They're M4 2x larges, which means they have 8 cores, 32 gigs of RAM per node. We split that. Half goes to the Elasticsearch heap, half is left for the OS page cache. For storage, we experimented a bit with the instance storage or using EBS. We ended up opting for EBS. We didn't see a huge performance difference, and the flexibility of size was something we really needed. So we were able to get the space we needed without increasing the per instance cost. So the data size, so it's 1 terabyte before replication, but we run with 2 replicas, so it goes to 3. We're not breaking any Elasticsearch records here, but we are. I think the way we query it is kind of interesting. So we're not looking for the 20 documents out of a billion. We in some cases need to count millions of documents. So it's, really, Elastic hasn't given us too much trouble, but it's a little bit of a different use case. Largest index is 400 gigs, again, before replication, and index of the most documents has 1.6 billion. So we're on 2.3.1, and we're pretty excited about 5. We'll upgrade as it comes out. We use doc values almost exclusively. So you guys familiar with doc values, the concept? I'll leave it to the Elastic guys to go into more detail if you're interested. But basically, it works out really well for aggregations like this, where we're not analyzing the text of documents. We're just counting words and kind of straight matches. We're running in a single availability zone for now. Just keep things simple, and we haven't had, I guess you don't have issues until you have them, right? But we'll see. We'll probably expand that at some point. We don't do any ranking or relevancy runs. Every query is an aggregation, or at least one. And we have this pretty novel, I think it's novel, backup and restore process. It moves prod data into a test environment, so we can run queries there before we run them in prod, get a sense for how they're going to perform. We have a blog post we just put up about that if you're interested. All right, quick demo. This will be pretty quick. So let's see. All right, so this is the new Centermark system. I'm showing this with, it's not a real client, so some of the numbers are weird, but you'll get a sense for how this all performs. So let's see. So this is a web dashboard. It's meant to provide a quick overview of performance of your website. So how many people are visiting it, where are they coming from, desktop or mobile, are they new or returning customers. This is, which search engines are people using to arrive here. This is like, what are they doing on the site? How long do they stay? How many pages are they looking at? That kind of thing. It's kind of what you'd expect of a web dashboard like this. So I'm going to look a little bit deeper into mobile versus desktop visits. So I can change the time range, and we give, this is, it looks like a small thing, being able to provide custom date ranges. It was huge for our customers since we didn't have it for a while. We're going to look at the last 12 months and group by, we're going to group by week. And this, again, seems like a small thing, like, oh, you're grouping by a certain time range, but we didn't have it for a while. All you had was monthly. And, you can go even down to the day. And you can see, I mean, like, it is not, putting up a sweat. Like, it's just, the data is like, as soon as you make the change, the data is in your face, which really, to me, makes it feel like a tool. Like, I'm able to get in here and get the data I need and make my way through it and find the answers I need. We also break people by the location. So this is kind of the overview of, how their network is performing overall. But you can say, okay, what's happening at this one location? What's the breakdown? Just to show the other thing we had, which was we only let you see the full franchise before, but now I can go in here and kind of hand pick the locations I'm interested in. I can make groups to make that easier, but I hit apply, and I get the data. In this case, just for the one location I chose. We've got trends. We've been able to add on to it as we've gone along without much trouble. And that was for 4 locations and over 1 year, which is okay, that's quick. But I ran it just yesterday on a real customer with 2,000 locations over 3 years, and it came back in 6 seconds, which is fantastic. Like, that is perfectly acceptable. Like, you're using this business intelligence tool. 6 seconds is not a long time to wait. And this chart on the bottom is like doing a comparison of this year versus last year, and that came back in, I think, 2 seconds or 3 seconds. So we've been just really happy. All right, last bit. I'm like 1 minute away from tying it up here. We realize that the speed that these reports are running is pretty important, and we can't really predict exactly how our customers are going to be using it. We give them all this control, changing their date range, all this other stuff. So we want to know, like, what's their experience really like. So we use New Relic for application monitoring, and we're able to plug in some like custom metric gathering pretty easily. So we just added, okay, every report that runs, report how long it took, and we're able to kind of throw up these charts. So this is showing, like, that green line on the top is showing the 99th percentile of report runs. You can see, like, there are some that took 15 seconds, but in general, everybody's experience is like sub 5 seconds on most every report run. And we're able to dig in a little bit to the 99th percentile and say, okay, which report were they running? Going a level deeper, we actually have a full list of every execution, and we can look in and say, okay, for that one that was slow, what were they really doing? How many locations were they looking at? What was the date range? How were they grouping things? So, you can see here, they ran a web visit duration report for this franchise. They were an internal user, so I know it was not a customer in this case. It was somebody, a Yodel employee. That request took 0.7 seconds for roughly 700 locations. It was over 1.5 years, and they were grouping by month. So, that's great. So we're able to follow up on any slow executions and learn and say, okay, this report needs some more attention, or what can we do to improve the experience? So that's it. That's the story, how we started with Hadoop and ended up with Elastic. Any questions you guys have? You can ask hard questions too. I'll just send them to one of the guys on the team or whatever. Yeah.
When you're doing bulk insert, are you taking all the data for, I guess, the whole records, or are you breaking it up? And if you're breaking it up, let's say you have 900 records and you're doing bulk inserts based on 300. And let's say one of the groups, there's a failure.
Yep.
How do
Yeah, so this is one of the reasons we ended up leveraging Storm. What we do with Storm and Kafka is there's a system called Trident, which Storm provides that does like transactional guarantees of stuff flowing through it. We opted not to use that. But what we do use is we won't advance the Kafka. Oh no, you know what? It's actually more interesting than that. It is interesting. So I probably should have like a diagram to explain it. But basically, we have like a few Storm nodes, and each of the Storm nodes is listening on partition of the Kafka topic. Okay, so this gets back to idempotency, and it's probably better on a whiteboard than me just kind of doing it with hand motions. But the thing that's most important for us is keeping order. So the order of messages flowing through the system can't change. They can't go out of order because we may have two messages. One represents, a session, and the next one represents some update to that session. And if we get them swapped, we'll have data in Elastic that's not accurate. But we use what is Kafka? It's like keyed partitions, something like that. Keyed messages that guarantee order within partitions, or they guarantee they go to the right partition, and then we keep Storm operating in order again. So if there's ever an error, what will happen is Storm will fail, try it again, and it will most likely succeed, but it maintains order. So we're able to keep things flowing. If we do have persistent failures in Storm, we get notified and we can respond. But it's kind of interesting. Keeping the focus on idempotency was keeping things in order and dealing with errors appropriately. Yeah. Yep. Yeah. Yeah, so the question was how many documents are we storing in those nodes and how do we know when we need to add, right? So I probably should just know the total number of documents, but given that the largest one is 1.5 billion and we have like 12 or so indices, it's probably under 3 billion documents, roughly around there. And I mean, we tend to monitor the just drive usage more than number of documents. We plan out the sharding strategy per index, so we know okay, how many documents are there going to be, how big is each document, how are we growing, so we kind of set up a sharding strategy that makes sense. But then we just monitor drive use, and that's really what's limiting us, honestly, is we don't have volume where we're doing, we're not doing 1 million searches a day or anything. When you think about just the nature of franchises kind of makes that true. Like they might have 1,000 locations, but there's like 2 or 3 people that are going to log in and use the system for those 1,000 locations. So we're not CPU bound, it's really just drive space. We just kind of monitor that, make sure we have headroom, but I don't know if that answers your question. It's not that exciting of an answer, honestly, on my part, but so yeah. So since we use doc values almost exclusively, heap usage isn't usually a problem for us. The queries just don't use a ton of heap. We have had a few issues in the dev environment where we're experimenting a bit and we cause problems there, but in general, we've never had a problem in the production environment with heap. Sorry? How many updates? Yeah. So they're not that frequent, but they happen. So really, the one that happens most frequently is somebody rates a lead. So they say, oh, this was a telemarketer or this is a hang up or whatever. People don't tend to do that often. So I mean, it's really not a huge amount. Yeah, I mean, it's not an interesting amount. I mean, it's like way less than 1% of our documents get updated, I would say. So, yeah.
Was Spark not in the consideration when you decided to do Elastic?
Yeah, so it was, but we didn't really look into it too deeply, to be honest. The question was, did we look into Spark at all? So I guess not really that deeply, no. Sorry. Yeah. Is Elasticsearch our main storage? No, not in this case. So in this case, if the data on Elastic were to disappear, I mean, one, we have backup, so we could restore from backup, but we could also pull in all the data from our Postgres database. Now, it would take us a few days to backfill it all, but yeah. Yeah, the data is it's either in Postgres or Mongo. We have some source data in hbase somewhere, but we're pulling it out of those stores and pushing it into Elastic for search. Yeah. 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 So that's a good question. So yes, how far the data goes back. So we decided that we'd rather have all of our data in Elastic, and even just have all the data for all customers. So the franchise division is the division that really has this tool available to them, but we loaded data for all Yodel customers, people who are not in franchises as well, and that means we're in a great position to produce advanced reporting for them also. So the data goes back to Yodel's founding, which is like 2007, 2008, and the growth curve is kind of interesting. So we probably put more data into the system every day now than we did in all of 2007. No, yeah, we don't do like rolling indices or anything like that. We just have everything's in this index, and it's been good. No. So so the question was, we use New Relic for monitoring. How do we get that data out of Elastic? And really, where we added the monitoring is in that reporting service. So there's one microservice that the UI is requesting all of its data through. We monitor the microservice exactly, and then all that microservice is doing, the majority of it is executing a query, and doing some serialization, and then pushing it back to the UI. So yeah, man. Yeah, so how long did the transition take? And I'm assuming you mean like dev time, not like physically moving the data, but how long it takes to build? Yeah, exactly. Yeah, so it's interesting that 100-line Python script I mentioned, where we were testing out Elastic, actually came in handy here. So we had a way of loading data, like all of our data, into Elastic. Right? I had this Python script. So what that let us do is split the work effort among two teams of engineers. One team was responsible for getting data from Postgres into Elastic. So they focus on Kafka, Storm, the bulk insert to Elastic, all this idempotency, all that stuff. Another team was able to work on, all right, given that there's data in Elastic, which we can get by running this crappy script, produce the UI and that Elastic reporting service to get the data out. So that split was pretty useful in reducing the time. And I would say, when did we start? Like October, November, maybe? And then, yeah, we were live in January, February, so it was like 3 months. And we started with, we've been adding more reports and adding features as we go, but we were live in front of customers pretty early in the year. So, yeah. Yep. No, it's a proxy, yes. We don't expose Elastic directly, no. Yeah, it's a REST service that we produced, exactly. Yep. So we run Kibana on this data set, but we don't expose it to our customers. So I'll use it to inspect things. Other parts of the business will use it to inspect things, but it's not part of the product. Exactly. Yeah, we produce our own charts on top of it. You've been trying for a while. We have a reindex. Yeah. So yes, if we have a reindex, yes, absolutely. So we run into issues occasionally where we have to go re-backfill. We've actually put a fair amount of dev effort into making that process really easy, because we don't want, like when we first started, Tony remembers, the backfill process was very manual. So it was like, run this bit of code, wait until it's done, and then run a bit of code again. So we were like running this like job every hour overnight or every 2 hours. It just took us forever because somebody has to go in and like babysit the thing. But we put a bunch of effort in now, so we can just kick off another backfill, get it all from Postgres, and move it through. We have not used the reindex API that Elastic has. We experimented once in dev, but decided we have this backfill process, and we are confident in it. We can just do that instead. So, yeah. Yeah, so the question is, do we have any security or permission requirements? Yes, in that we don't want we want to keep the data private. We don't want to be showing one customer another customer's data, that kind of thing. But in terms of we don't use Shield, for example, on this data set. We just have that service that is guaranteeing based on your user, who you are, what data can you get access to, and we just query for that. So all the customers are stored in the same index. Yeah. Right. Yeah. Exactly. So we keep the data separate by leveraging the reporting service, not through any Exactly. Yep. All right. Cool. Yeah. No. No. So the question was if we had split brain. No, we haven't had any issues with the cluster. I mean, trying to think of. No. I mean, the most interesting thing we did was just kind of add new nodes. We were expanding the drives, and I did this the first time I had to expand the drive. I went into EBS, took a snapshot of the drive, gave it a new drive restored from that snapshot, and told Elastic or restarted the node with the new drive. That process again was really manual and took a long time. The snapshot took a while. The restore was instant, but then it's backed by S3, so the drive is really slow for a while. So we said that's not a great experience. So what we did for the rest of the drives is just restart the node with a new empty disk, and Elastic is oh, it looks like you lost 1/5 of your drives, and it just Elastic dealt with it. It was much faster and way easier than trying to do it with the EBS snapshots. So I mean we haven't had any real clustering issues. So yeah. Yeah, so the question is why we're running it on EC2 native instead of with the Amazon support, the Elastic service they provide, right? So one is we were already kind of underway when Amazon announced that. We were pretty excited about the features in 2.0 that Elastic had, and Amazon was announcing a new product using 1.5, and I think they're still on that. And it's also the level of control we get over the cluster is really not there in the Amazon service. We've made some adjustments to our cluster that I don't think Amazon provides. Really the only one we've done that's interesting at all is the number of search, the terms we can search on, because we have a lot of owners, 2,000 in some cases, and we had to adjust that there. But I mean, and we did the vendor lock-in with Amazon. We're probably going to move the cluster in-house at some point. That's where our other Elasticsearch clusters are, and Postgres and all this other stuff. So just the ability to move it around. All right, I've done a ton of questions. Do you have any more questions? You can find me. We have a few other Yodel engineers here that kind of maybe know better. So that's it. Thank you all. Appreciate it.
All right, thanks, Mark. That was awesome. I love the. You definitely put a good amount of time in those graphics too. I can tell.
It's really not just Google Images.
Yeah.
Put very little time, but yeah.
Still, nice job. Nice job. All right. Well, thanks. So, if anybody has questions, I'm also here with Dave. He's a solutions architect out of the DC area. So maybe we've got tech questions or sales-related questions or anything like that. Doesn't matter what it is, Elasticsearch or even the other product suites, so like Logstash, Kibana, etc. If you feel free, go ahead and fire them away. If not, we'll then wrap up and everyone can socialize. Or did Mark do such a good job answering that we were on easy street here? Sure. question about document values and what that is? Sure. So basically, when we do document search in information retrieval, we build the inverted index. And the inverted index is basically like just in the back of the book. So instead of having a document and its values, you have the terms in all your documents and then what documents those terms are in. So it's inverted. And that's a great data structure for search. But when you need to do two kinds of things. One, you need to sort your search results by something other than the native relevancy score. So you might search by date or search by this numeric field. And the second thing is when you're doing the aggregations. And as Mark said, that's pretty much 99% of what you do. Those two activities, the inverted index is no longer a good data structure for that. So we need to uninvert the inverted index. We basically build a column or data style structure, and that's what we use for the sorting and the aggregations. And there's two ways that we can do that. One is how Elasticsearch did it by default from prior to 2.x, and that's with something called field data. And essentially it was, think of it like a cache miss. When you went to go do that search or that aggregation, and it needed this uninverted inverted index, we would on the fly go build that data structure and cache it into the heap in the JVM on the nodes. And then once it was built, it was blazingly fast and everything, but it was primary consumer of heap memory and what caused many people's nodes and clusters to OOM.
Maybe second after rivers.
Yeah, well, yeah, correct, yes. Those were a big one as well. And so we work towards doing this doc values, and yes, the names sort of suck, we know this. Doc values, we did the same, we built the same data structure, but we did it at index time. So when you index and we're building those inverted indices, we basically create that data structure, so pre-compute them, and store them on disk. You no longer get this like cache miss behavior, and you no longer consume Java heap memory for this stuff. The cost that it comes at is you get some more, you have to have more disk space, and you get a slight hit of about 10 to 15% based upon your data at index time. But you basically can avoid the memory. And as I think Mark mentioned, they're running 16 gig heaps on their nodes, and you're not bumping up against that as a scaling bottleneck. It's your storage right now. So.
Yeah, I thought of lowering that.
Yep.
And just giving it all more to the page cache. So we have it done.
And to that point, was it Jason? I forget who on our team. I think recently there's a blog post that came out all about the heap sizing and goes into experiments about like, okay, should I just always give it more because I can, or is that actually detrimental? So, yeah. And the page cache that he's referring to is that when we touch, every file that Elasticsearch writes is immutable. So we write it, we don't update it. So when we ask for it back from the OS can say, hey, nobody touched it or changed it since the last time you asked for these blocks of this sector. I'll just give it to you straight from memory as opposed to hitting the spindle. So we leverage that a lot.
I think the one thing I'd point out about doc values is the decision for the Elastic user happens when you create the mapping. Right, so this isn't something that you do at query times, oh, hit the doc values version, no, I want the inverted indices. It knows which is the correct one to do because it's how the field is being stored. So that not analyzed decision is now the default for that is doc values over field data. If you wanted the field data back, you could do it. Some people are just raw speed, they're doing high throughput, kind of trading, kind of smaller data sets. They just want, they're not willing to sacrifice the 15% or whatever it is. They want it out of heap, please. But the decision happens when you create the mapping. It's almost like a schema decision for that index. And we're seeing that some of the assumptions about Elastic, if you read a blog that's even a year old, some of those assumptions have changed. We're getting reports from our teams who are helping out Blizzard do some of their analytics where the data is way beyond the amount of RAM that they have for like monitoring some of these, e-gaming Overwatch clusters that are like figuring out which characters to nerf and all this stuff, right? Like they're running on machines with lots of RAM and they're given more of it. to heap sometimes, and they give him more of it to the doc values. Basically, anything you don't give to heap goes to the OS, and that is what doc values is consuming, almost like memory map files. So that's the first point, is that the assumptions are changing. We are learning as we go. 5.0 might even push that farther, right? Because the doc values data structure underneath is switching Lucene versions. Right? We're going from Lucene 5 to Lucene 6. It's getting faster, right? So assumptions will sift as you go. The second thing is that when it does come time to be query time, you don't have to care about any of this stuff. Right? The optimizers in Elasticsearch are going to do it for you. So if you ask a query that is like a Boolean of full text search, geospatial, which is a whole different data structure, time series stuff, so that would be one of the doc values things that's been indexed. It's ordered, this field, break it out separate into a columnar index, right? And maybe a whole bunch of other constraints, some of them fuzzy. That query is all running against Elasticsearch still. It's not like, oh, I'm doing one or the other and then some big massive join. That's done for you, right? So the ease of use is still there. This is like a mapping time decision. It's all built to work together.
Yeah, so in those cases, right?
Yeah, so if you're doing analytics, oh man, look at doc values. Like, save your life. Yeah. So the time frame for 5.0, the exact release date is deleted. I'm not allowed. Yeah. Redact. Yeah, we have no idea. The engineers I'm talking to are targeting late summer, whatever the hell that means. It's going to be out when it's ready. It's a major release, right? So just like 1.7 to 2.0 has, like, you wanted that done well, because that's a big transition for people's apps. It's going through QA. It's currently in like Alpha 4 or something, Alpha 3, Alpha 4-ish. So, it's going to go to betas and release candidates after that, and then it's going to get released. So we're almost at the point where it's feature complete. Like, now it's just, okay, that's all that made it. No more late stragglers. Cut it off unless, the biggest cluster in the world wants it or something, right? Yeah, so we're getting there, but I think in late summer. Early fall.
Engineers all over the world too, so the definition of summer and winter may be skewed.
Oh yeah, we say this in engineering meetups, and the Australians are like, "Could you please tell us the calendar month?" This is annoying. Biggest cluster in the world. I think the biggest public use case right now is probably FireEye, and most of the biggest clusters in the world are more than one cluster.
Yeah.
They're super clusters, and they're federating between them. Right? They actually use a cluster per data type, because now they're pushing petabytes, and it just makes more sense. Why have to tune for two different workloads in one cluster? Just federate, and they actually put a data type per cluster, even if it's in the same region in Amazon.
And that cutoff usually ends up around the 200-ish mark.
For nodes?
For cutting off, like, no more than this cluster to another one.
I've got customers with single clusters with about 4,000 nodes, but I suspect it's because they get VMs that are only so big from their VM provider. I don't think it's an Elasticsearch constraint. Still works, but they're all on the same network, and that helps.
One thing I want to add about the V5. Oh, can you hear me? Oh, sorry. We have something called the Pioneer program, right? If I've said that correctly. So Alpha version 3 is out right now. Alpha 4, we just got an internal release candidate. It'll probably be out soon. Basically, if you file a legitimate bug that somebody else has not reported, and it's actually one that we found, yep, we verified that's a bug, for either any of the open source projects, so Logstash, Kibana, Elasticsearch, Beats, then you'll get part of, you're in the Pioneer program, you get like a little gift thing at launch time and some thanks and stuff like that and a name somewhere. So it's worthwhile, like, to give it a try and play with it. It's not perfect, obviously, but we're trying our best. So if you feel so inclined and you're playing with 5.0 with the alpha and you find something, don't hold back and say, oh, I bet they already know about this. Go actually look, and if you don't find it, submit a bug. So
I don't know if it's a motivating factor, but they gave out special stickers for pioneers in the 2.0 program. I don't know what's going to happen. There's no commitment here.
You are in a raffle tickets to ElasticCon
Yeah, there tends to be stuff associated with it, even if it's just sticker pride. Any other questions? What's up, Joe? So, full disclaimer, the investors in New Relic are the same as the investors in Elasticsearch. The technologies definitely have overlap, right? There's no way to kind of not see that, right? Sometimes when I talk to New Relic users, they're kind of at the point that the Centermark people are where the data's fuzzy. I can get to this point and it's awesome. It did it all for me. But now I want to sort by this and do this or get to the raw thing or something. And if it didn't get set up to do that, it may not be fast, it may not be possible. It probably can do it. It's an awesome tool, right? So when you hook up when you tend to hook up a connector for a plugin for one of these APM tools to Elasticsearch or really any distributed system, it gets you the stats that are available out of the public UIs, APIs. You can just hit Elasticsearch and say, how many queries did you do in the last 5 seconds? And it tells you. And that's the kind of stuff they're pulling. They're pulling JVM stats sometimes. If you leave those turned on, it's pulling machine stats, and it's got those all aligned and correlated, right? So I can say, oh, this is the CPU, and this is, this is the query, so I'm probably CPU starved, right? You can learn some of these things. But then I get the question of, oh, I had an outage here. No, that was a rolling upgrade. New Relic has no idea, right? Like, oh, all your data disappeared. No, that's a reindex, right? Actually, I scheduled that, right? So if you use, I tend to see people using New Relic for like, this is my global dashboard. And then they use something like Head or Cough or Marvel or something like that. This is my diagnostic tool when I really have a deep Elasticsearch question. I might have my central alerting for all of my infrastructure all here because I don't want to have that job, right? Or maybe even if I'm detecting alerts in Elastic, I'm going to push incidents to New Relic because I want one central place for all of them. But now when I have a question, I got my Elasticsearch experts, I got the Elasticsearch support on the phone, whatever it is, I'm going to be looking at screenshots of Marvel because that's like the diagnostic tool for figuring out what happened. Why did that thing reboot? New Relic doesn't know, but I might have it in here. And that's kind of the divide. That's how I see a lot of people doing it.
One final thing.
Yeah, one final thing, a shout out. Community shout when we're...
Yeah, so we're always looking for other people to speak at these meetups. So if you want to speak, if somebody you know wants to speak, who you want to host, etc., just message on the meetup group or email meetups@elastic.co, and we'll help with the scheduling and the coordination and all the stuff that's not fun. We'll help with all that, and you can focus on actually delivering that cool talk and discussion. So don't be hesitant. We're here to help.
Whether it's a lightning round talk, a 10-minute, here's my quick demo, I built this, I hooked this to this thing. I don't know if anybody's ever done that before. Conversation starters as well as tell me about this whole big project you did. We love it all, right? Cool. And as you can see, the Q&A is often most interesting when we're talking to a user and not just us, right? Because we have the same answers every month.